Hello students, today we are going to discuss spectra of alkali atoms. We know that alkali atoms are the atoms which have only one electron in their valence shell. Atoms will have one electron in their valence shell. For example, hydrogen, lithium, sodium, potassium, etc. For the alkali metals, their general configuration is NS1. For example, in case of hydrogen, Z is 1, its configuration is 1s1. 1 lithium, its Z is 3, its electronic configuration is 1s2, 2s1. It means that it has one electron in the outer shell, which is similarly sodium having Z equal to 11. Its configuration is 1s2, 2s2, 2p6, 3s1. It means that it has also one electron in the outer shell in the S state. So all the alkali atoms will possess one valence electron in the outer shell, and that is present in the S state. So as to discuss the spectra of alkali atom, we will start from the very simple example. Firstly, spectrum of hydrogen atom. Spectrum of hydrogen atom. We know that hydrogen is the simplest atom which possesses only one electron in the first s orbital. So now in this case, the energy is given by minus m e raised to power 4 by 8 epsilon n square h square. It means that from this formulation we can find out the energy of each shell by substituting the value for n. For example, for n equal to 1 means for the first shell, the energy is given by minus m e raised to power 4 by 8 epsilon h square, which is minus 13.6 electron volt. The spectrum of the hydrogen atom is due to the transition of the electrons from higher energy state to lower energy state. So the spectrum of hydrogen atom is a line spectrum. But all the transitions in the spectrum are not allowed. So as to consider the allowed transition, we will have the selection rules. Selection rules for hydrogen spectrum are delta L plus minus 1. It means in case of hydrogen spectrum, we have mainly 4 series. First series is called as principal series. Second series is sharp series. Third series is diffuse series. And the last one is fundamental series. We know that for the hydrogen atom, the ground state is 1s1. We know that for the ground state configuration, we know that for hydrogen atom, ground state is 1s. So series is the series formed by all the transitions from Np to 1s, because we know that for P, L is equal to 1, and for the S, L is equal to 0. It means that delta L is plus 1, which is satisfying our that these type of transitions are allowed, and all these transitions which are coming from Np to 1s, they will form a series which is called as principal series. In the same way, sharp transitions which are starting from Ns to 2p, they will form a sharp series. In this case, the value of n is 3, 4, 5 and so on. For the diffuse series, all the transitions that will start from ND to 2p. In this case, again the value of N is either 3, 4, 5 and so on. And the last one, which is the fundamental series will start from NF to 3. Again we will check the difference of the L is satisfying the selection rules or not. So for the F state, we know that the value for L is 3. For D, the value of L is 2. It means that delta L is +1, so which is also satisfying our selection rules. So now what we have ground state configuration for the hydrogen atom, which is n equal to 1, and for this n equal to 1 we will have 1s orbital. Now for n equal to 2 we have 2s and 2p state. For n equal to 3 we have 3s, 3p and 3d states. 3s, 3p and 3d states. Now the next one, n equal to 4, we have 4s, 4p, 4d and next is 4f. So from this energy level diagram we will draw all the 4 series. We know that the first series is principal series, and principal series will start from NP to 1s. No restriction on the value of N for the transition to occur. So we have a transition from 2p to 1s, 3p to 1s, 4p to 1s. All these transitions which are falling NP to 1s, they will form a principal series. So all these transitions, they will form principal series. Now next one is sharp series. So for the sharp series we have NS to 2p. So this is level 2p. So all the transitions from 3s, 4s, 5s and so on, they will form a series which is called as sharp series. So this is our sharp series. Now next one is diffuse series. Diffuse series is the series which contains all the transitions from ND to 2p. So we have a transition from 3D to 2p, from 4D to 2p, from 5D to 2p, and they will form diffuse series. And this is diffuse series. Now the last one, fundamental series. So all the transitions from NF to 3D, they will form a fundamental series. So now we know that F orbital starts from 4th shell onwards, and so a transition from 4F to 3D, and from the next one, if next shell is 5th shell, and this is 5S, this is 5P, this is 5D and this is 5F. So a transition from 4F to 3D and a transition from 5F to 3D, all the transitions from NF to 3D, they will form the fundamental series. So we have basically the 4 series. First one is principal series, second one is sharp series, third one is diffuse series, and last one is the fundamental series. So this is our spectrum of alkali atoms, and particularly we have discussed the spectrum of hydrogen atom. So in the next lecture we will discuss spectrum of the sodium atom. Thank you.